Good morning, everyone. Myself, Angri Omkar. I'm going to teach you Fick's first law in a subject transfer phenomena. So here we go. Fick's first law of diffusion. Introduction to this. It is in this we will explain mainly the diffusion of particle, where we know that from higher concentration to lower concentration, the diffusion takes place. Uh, there is no external force required for this. Occurs due to random molecular motion. It is known as molecular mass transfer. What is diffusion? Movement of molecules to balance concentration difference is known as diffusion. It can occur in um, solids, liquids, and gases. Uh, for better example, I'm teaching you that if we place a incense stick or a perfume, we spray at one corner of the room, and it after some time we can smell that incense stick or perfume smell at the other end of the room. It takes in diffusion. So this is called diffusion process. Uh, Likewise, we have many examples of them. Visualizing diffusion. This is the picture. Here we can see the diffusion takes place from higher concentration. The particle move towards lower concentration, and the diffusion takes place. It takes some time for the diffusion. For some particles, it might be taking half an hour or some. It depends upon the concentration and diffusivity medium. If we keep air in the same like perfume, if we keep fan, the diffusion takes place very faster, and um, the diffusion takes till the equilibrium is attained. The driving force is the concentration gradient in this. Next, here we go. Fick's first law, the fundamental law of governing diffusion. Mass flux is directly proportional to the concentration gradient. This relationship tells us how fast the mass transfer will occur. This is the definition. And here is the mathematical equation for diffusion. J equals to minus dAB dCA by dy. Let's break this equation. Ja means mass flux and dAB is diffusion coefficient. dCA by dy is concentration gradient. And here the SI units of the uh, mass flux and diffusion coefficient concentration gradient. Mole per meter square is for mass flux, meter square by second is diffusion coefficient, mole per meter cube per meter is concentration gradient. Next, here we go, mass flux Ja. The definition, the amount of mass or moles transferred per unit area per unit of time is known as flux. Here, key concept of this is higher the flux means the faster the rate of transfer. Rate transfer. Next slide. Diffusion coefficient DAP. This represents how easily molecules can move through medium. High diffusivity, the molecular movement is faster. For example, we have gases. For low diffusivity, there the molecules move very slow. And for example, in solids we have um, examples like uh, if we take examples in solids, we have many, and in gases like earlier I said this perfume, etc. And liquid, like if I mix some sugar in a one glass of water, then we can do that. We go for diffusivity in different phases. For gas, it will be 10 to the power of minus 5, which is faster. For liquid, it will be moderate, 10 to the power of minus 9, moderate. For solid, it is like 10 to the power of minus 10 to 10 to the power of minus 14. Next, we go for what is differences. What is the difference between the gases? Molecules are far apart, easy to liquids. Molecules are closer, more collision. Solid molecules are packed tight, very tight to move. Here we can see particle arrangement in phase of matter, solids, liquids and gases. Particles are packed tightly together. In fixed arrangement, particles can vibrate but not move. In liquids, particles are closely together with no distinct management arrangement. Particles can move and slide around each other. In gases, particles are freely floating with no distinct arrangement. Particles can move and collide with each other. Concentration gradient dc by dy, the driving force. It represents the change of concentration with distance. Steep gradient, large difference in concentration result faster diffusion. Gentle gradient, small difference in concentration results slow diffusion. Significance of negative sign. Why it is negative? Mass moves from higher concentration to lower concentration mathematically. The gradient slope is negative in the direction of the flow. So in the direction of flow, it is gradient. So the slope will be negative. The negative signs cancels out to make flux positive. Next, real life examples. Like we said, we have taken that perfume molecules diffuses from higher concentration at the nozzle to the low concentration of the room. Lungs oxygen diffuses from air in lungs concentration into the blood low concentration naturally. Importance in engineering. Fick's first law is the foundation of designing major equipment like distillation column, gas absorption, drying. Uh, in distillation column, separating chemicals, gases absorption, removing pollutants from air, drying, removing moisture from solids. Visualizing the process, higher concentration to lower concentration, the diffusion takes place. Driving force is gradient. Tank conclusion. Fick's first law describes mass transfer due to concentration difference. Mass flux is directly proportional to a concentration gradient and diffusivity in the process. Property controlling diffusion. Thank you.